If your LLM alternates between essays and one-liners, prompts alone won't save you. I'll show practical length control, budgets, stop rules, and penalties that make output predictable. You know the pain. One run gives a novella. The next gives 2 lines. That breaks pipelines, inflates costs, and frustrates users. By the end, you will know 3 simple levers in Python that let you hit desired output size reliably and cheaply. You will be able to build outputs that stop where you expect them to and avoid runaway verbosity. I'm Professor Pi, teaching AI engineering and LLM systems from basics to advanced, with simple, concepts-first Python that helps you solve bigger, real-world problems. Length control matters because models do not understand your intent for size unless you give them mechanisms. In product systems, you need predictability for cost and latency. That means bounding tokens, cutting at safe boundaries, and preventing loops or repetition. These techniques sit between prompt engineering and model configuration. They are practical, cheap, and they slot into existing code without retraining. The common alternative is to rely on temperature or vague word counts, which is unreliable at scale. At a high level, think of 3 knobs. Budget is a hard cap on how many tokens you allow. Stop rules are phrases that say where to cut. Penalties block repetition and loops. Combine them and you get a predictable envelope for output. For example, a budget of 100 tokens buys a short paragraph. A stop phrase, like end of answer, guarantees a safe cut. A repetition cap avoids a single phrase repeating until the budget runs out. We will build a tiny deterministic generator and layer on stop rules, a budget selector, and a repetition penalty. The final result prints a guarded, predictable output so you can measure length, cost, and latency in development. Now we'll start with a fixed token budget. This snippet clamps output length with a fixed token budget. The list words is a tiny, deterministic vocabulary that will cycle through. The function gen takes a budget and returns exactly that many tokens by indexing words with wraparound. There is no randomness and no external calls, so cost and latency are fully predictable. Increase budget for more detail and cost. Decrease for tighter, cheaper responses. The printed text shows 12 tokens produced under the exact budget. This pattern is useful to prototype how many tokens your prompts consume and to set a hard limit before you add any other safety checks. Next, we will add explicit stop rules to cut at safe boundaries. This example enforces hard stop rules that truncate when a stop phrase appears. The variable stops lists phrases that should end the output early. The function gen builds a budgeted string, finds the earliest stop occurrence with find, and slices the text just before it. Using rstrip removes any trailing space from the cut. Add more stop phrases to guard boundaries like sections or signatures. More or earlier stops will shorten the reply. The printed text ends exactly at the first stop, proving the cut worked. Stop rules are handy when you expect structured replies with known delimiters. Next, we'll choose a budget that best matches a target length. This code picks the budget that best hits a target token length. The variable target expresses the desired number of tokens, and budgets lists allowable caps you are willing to spend. The expression with min scores each budget by the absolute difference between produced tokens and target, then selects the closest match. The result chosen is the generated text using that winning budget. Higher target tends to select larger budgets and raise cost. Lower target pulls it down. The printed line shows the chosen budget and its text, confirming the selection. This lets you trade exactness for cost by limiting possible budgets. Next, we will add a repetition penalty to stop rambling loops. This snippet applies a repetition penalty that caps how many times a token may appear. The list tokens comes from the generator without stops, giving a raw stream. The dictionary scene counts token frequencies as we scan, and the list out keeps tokens only while their count stays within max repeats. This is a cheap guardrail to cut rambling and loops without changing the budget mechanism. Increase max repeats to allow more detail and possible redundancy. Decrease it to tighten outputs further. The printed text shows a once per token summary after penalization. This approach is light and works well when you cannot change the model internals. Next, we will combine all three controls into a single guarded pipeline. This code combines budget, stop rules, and repetition penalty into a stable baseline. The call to gen uses a budget computed with min to enforce a soft target against a hard max, then applies a stop phrase to cut early at safe boundaries. The scene dictionary and comprehension cap repeats so verbosity cannot explode, even if the budget allows it. These three controls work together to bound cost, latency, and runaway length. Tighten stops or lower max repeats for stricter limits. Relax them for more detail. The printed length and text verify a predictable guarded output, which is ideal for production pipelines. Recap what it is: 3 simple levers that shape output length in code. When to use it: whenever you need predictable costs or safe UI responses instead of free-form model output. One caveat: strict limits can cut useful content, so tune with real examples. Next step: pick one parameter and tune it against the corpus. For example, vary max repeats and measure quality and token cost across 100 prompts. If practical AI engineering helps, subscribe and watch the AI engineering videos.